This video is going to cover the topic of the volume of 3D shapes. Be sure the date and topic are at the top of your page. The essential question that will guide this video is how do we calculate the space inside a 3D shape? As many of us know, volume is the space a 3D shape occupies. Another way to think about volume is that it is how many cubes could fit inside an object. And it's this cubic measurement that has us use the notation cube when we're dealing with volume. So we might see inches cubed or feet cubed. Rather than the 2 for square that we see in area, for volume we see cube. It's cubic feet, cubic inches, and so on. Now some of us may be thinking, I know how to find volume. My teacher last year taught me that to find the volume, I just need to multiply the length times the width times the height. And that's true sometimes, but not always. That will work with a particular type of object, but not with every object. So instead of using this length times width times height, I think there's a better way for us to think about volume. I'm going to show you how to do that here. I'm going to start with our friendly rectangular prism. So to find the volume, I'm essentially trying to figure out how many cubes can fit inside this object. To think about this, I'm going to think about the layers of cubes that I could put in here. And I'm also going to need to look at the base of this entire figure. So this is going to be a term that I use a lot, and this is going to be base with a large capital B, and there's going to be a difference here. So in this prism, I can see how many cubes fit on the bottom layer. If I were to cover this entire bottom layer with cubes, I would be able to fit 12 cubes along the bottom, right? And I can figure that out by essentially finding the area of the bottom of my figure, right? So I'm going to find the area of this big base, the whole bottom of my 3D shape. And I'm going to do that in this case by multiplying my length times my width, or 3 times 4. So I find out that there are 12 cubes here. Once I know my base layer, my next job is to figure out how many layers it would take to fill this, right? So I could see that if I kept going, right, I could fill another 12 layers in here, another 12 layers, and so on. The number of layers is going to be dictated by how tall this is, right? So this is 6 inches tall. So if each of one of my layers is 1 inch high, I'm going to have 6 layers. So what I'm doing there is taking my base layer of 12 and multiplying it by the height of 6 to see that my volume is 72 inches cubed. I could fit 72 cubes that are each an inch by inch in my entire shape. So some of you may be thinking, oh, but didn't you really just multiply your length times your width times your height? And in this shape, I did, right? But more importantly, I found the volume by multiplying the entire area of the base. Look at that capital B, that's really important. I'm multiplying the entire area of that base by the height because I'm taking the number of cubes in one layer on the entire base and multiplying it up by how tall my figure is. This is important because I can use the same strategy to find the volume of a triangular prism now, which I would not be able to do with length times width times height. So I can take this same strategy of finding the volume by finding the area of the base with a big B and multiplying it by the height even when I have a shape like a triangular prism. But in this case, the area of my base is a triangle. So I'm going to have to remind myself that I have to first find the area of a triangle by multiplying the base, notice it's a little b this time, times height divided by 2. So my triangle here is 2 inches by 2 inches. I have to cut that in half. So I'd have 4 times 4 divided by 2, which of course gets me back to 2 inches squared. So that tells me that the big base here is 2 square inches. Right? And that's how many cubes would fit along the bottom. But now that I know that, I can say, well, if that's how many cubes would fit along the bottom here, and I have 5 rows, because my volume needs to fill up all 5 layers of this shape, then I can multiply that by 5, and I can see that my volume is going to be 10 inches cubed. I'd be able to have 10 cubic inches inside this. And that wouldn't have worked if I had tried to use the traditional length times width times height, because in this case, that doesn't apply to a triangle. So it's important to be able to find the area of the entire bottom of your figure and then scale that up as tall as your shape is by multiplying it by the height. So remember, the essential question of this video was how to find the volume of 3D shapes. And I'm going to leave you with one for you to solve for us to bring to class. So we have a triangular prism with a 10-inch height and then a triangle that is labeled with a base of 3 and a height of 2. So you're going to use the formula big B times H, knowing to first find the area of that triangle to help you calculate that and bring that into class. And we'll, of course, practice this more together, but this should serve sort of as a review of what we've worked on in the past.